Hi folks, welcome back to the known cross-sections practice. In this video, we're going to take a look at question number 3 and question number 4. Alright, so we still have the same two functions that we had in the first two examples, where we have f of x equals the square root of x, and g of x equals the negative square root of x. And again, that appears in our diagram sort of along this part, that's our f of x. And then this bottom part here is our g of x. Now I've added in an ending point so we know where to stop for this. And in this case, we're going to just stop at 1, 1 and 1, negative 1. Now let's take a moment to draw this diagram in a more traditional way. So I have my y-axis, I have my x-axis, and I'm going to go ahead and draw my f of x. As well as my g of x. Now this time, the shape that we have inside of our parabola, that is a quarter circle. So this right here is the radius of the quarter circle. So if I were to draw the same green line here, that line would represent the radius of the quarter circle. Now I find it really helpful to annotate what these things mean so that when I go to use my area equation, I already know what information I have. Okay? Now before we write out our equation, let's draw a couple more sample slices so we know, are we doing dx or are we doing dy? So if I draw one here, and maybe another here, and then the last one here, all right? All four of these are going to be perpendicular to the x-axis, which means that I'm going to be using dx to set up my integral. All right, so we've got volume equals the integral of a to b of the area, and in this case, we're using dx. In another situation, we might use dy, and that's why I want us to think about what we're doing from our diagram each time. All right, so what is the area formula for a quarter circle? Well, that's going to be pi over 4 radius squared dx. And let's go ahead and fill in the information we have. So I know that my smallest quarter circle is going to be at 0, or this point right here. And the biggest one is going to be at 1, because that's what I chose as my ending point, 1. I'm going to bring the pi over 4 out to the front because it's a constant. And now I need to think about, how do I represent the radius? So the radius of the quarter circle starts up here and goes all the way, this top part and the bottom part. And so that's like what we saw in example 1. And so that means that that distance is 2 times the square root of x, because it's the square root of x is the top part, and then the bottom part is another square root of x. So when I add them, I get 2 square root of x. Okay, now let's simplify and evaluate. So I've got pi over 4, the integral from 0 to 1 of 4x dx. And I'm going to bring that 4 out to the front, so I'll get pi, the integral from 0 to 1 of x dx. Now let's integrate. 1/2 x squared, and I'm going to plug in a 1, and I'm going to plug in a 0. All right, pi over 2, 1 squared, minus pi over 2, 0 squared. And I know that this whole second term goes to 0. And so my final answer here is just going to be pi over 2. And pi over 2 represents the volume when I have cross-sections that are quarter circles stacking along the x-axis from 0 to 1. All right, So that's question number 3. Let's go ahead and take a look at question number 4. All right, so question number 4. A triangle with a height equal to 1/4 of the length of the base. That's what that triangle in this shape is, okay? So we can see that the base is 4 times as long as that height. All right, let's draw a more traditional diagram. Got my y-axis, my x-axis, my square root of x, that's my f of x, and then my negative square root of x, that's my g of x. And my ending points that I chose for this one are 16, 4 and 16, -4. Okay, so what does that green line represent? The green line would be like this, because it goes between the top curve and the bottom curve, and that represents the base of the triangle. Now that's going to be important because we know that the area of a triangle is 1/2 base times height. All right, so let's set up our integral. We know that volume equals the integral from A to B of the area, and we're going to do dx because these green lines are stacking along the x-axis, or they're all perpendicular to the x-axis. Now let's find the area formula we're going to need to integrate. Well, the area of a triangle is 1/2. I know that the base is 2 root x, and then the height is going to be 1/4 of that. So 1/4 times 2 square root x dx. So this one is a little bit more complicated in terms of the formula, but if we combine some like terms, I think it won't be quite so sticky, okay? So let's get our bounds in here from 0 to 16. I've got this 2 and that 2 cancel. This 2 and that 4 cancel to 1/2. So all together, I have a constant of 1/2 that I can bring out to the front. And then I have square root of x times square root of x, which is x dx. So even though that last line was pretty tricky, the next one showed that it simplified pretty fast. All right, let's take our antiderivative. 1/2 x squared, plugging in 16 and plugging in 0. So 1/4 times 16 squared minus 1/4 times 0 squared. And this is going to go to 0, which is going to leave me with 16 squared. And then I have to divide that by 4, so I'm going to get a volume of 64. And so 64 represents the volume of this shape when the cross sections are triangles with the height equal to 1/4 the length of the base. All right, so we're going to stop here for video 2. Come on back to see the last 2 examples worked out, numbers 5 and number 6. All right, see you there.